Section 9.5 is completing the square. I can solve quadratic equations by completing the square. Big ideas for this section. Any quadratic equation can be solved by first writing in the form m squared equals n. In general, we can change the expression x squared plus bx into a perfect square trinomial by adding b divided by 2 squared to x squared plus bx. And this process is called completing the square. It's finding the value that if it was added as our constant would make that a perfect square trinomial. So we take our middle number, b, the number in front of our linear term, half it, and square it to complete the square. So here, finding the value to complete the square, we want to know what number would we have to plug in for c in order to make this a perfect square trinomial. Remember, perfect square trinomials come from a binomial squared. So in order to do that, guys, we take our b value, the number in front of our x, we half it, and we square it. So negative 16 divided by 2 is negative 8. And when we square that, we get a positive 64. Keep in mind that whenever we square a number, guys, it's positive. So here, c would equal 64. And that's the number that would turn this into a perfect square trinomial. It'd be x minus 8 squared. Now feel free to pause here and give this a try if you'd like. Again, to figure out what value for c we'd have to add here, we take our b term. Okay, remember it's ax squared plus bx, so the number in front of our x squared, our coefficient there. We half it and square it. 20 divided by 2 is 10, and when we square that, we get 100. So 100 is my c value. That's the number that we'd have to square, or to add here, to make this a perfect square trinomial. On example 2 here, we're going to solve by completing the square. This video right here, which you guys are not going to be able to click on, it's going to take you to quadratic payphone. So if you put that into YouTube, I'm not going to put a YouTube video in my video, but that'll take you to, it's Mr. Boardman. He does he walks you through the steps of completing the square to get the quadratic formula. And we're not at the quadratic formula yet, but we will be. But the steps there are useful. And they're kind of catchy. They might get stuck in your head a little bit, and that walks you through the steps there. But ultimately, what we're trying to do, guys, is we are trying to find the solutions of this equation. And it's not just something that we can take the square root of because we have the x term here. So anytime we have an x squared, a quadratic term, and a linear term, we have to come up with a different way. So we've done using the zero product property with solving by factors, but here if I multiply to 16, and add to 14, not going to work there. So we are going to complete the square. And in order to complete the square, guys, I need to know what number I'd have to add to that side to make it a perfect square trinomial. So in order to do that, we have to move the constant to the other side. We don't want that number there. Okay, I want x squared and bx because I need to figure out what number for c I'd have to put in to make this a perfect square trinomial. Okay, so we move the c term that we have to the other side, and in order to do that, I get rid of it by subtracting here in order to get it so that we have just x squared and bx. Now we can complete the square. So I take my b value here, half it, and square it. Negative 14 divided by 2 is negative 7. Now we square that and get 49. And I add that in as my c value. But whatever I do to one side, guys, remember we have to do to both. Okay, whatever I do to one side of an equation, I have to do to both to keep it balanced. Now, we're going to write this as a binomial squared because we have a perfect square trinomial. That was the whole purpose of adding that 49. Here, the number that multiplies to 49 and adds to 14, they're both going to be 7s, and it's going to be a minus 7. And that's because that's the number that we used to square to get here. Okay, this is a perfect square trinomial. X squared is x times x, 49 is 7 times 7. And if we multiply those together and double it, we get negative 14. Guys, we can see that here. If I just put the x for my x squared in where I did my work here to complete the square, I get my binomial factor. When I simplify the other side here, I get 33. Now, solving this problem from here is the same as we've done before. We're trying to get x by itself. So the first thing we do is get rid of the squared. And to get rid of a square, we take the square root. When we take the square root, guys, remember it's plus or minus the square root there. To get x by itself, I need to add 7. So x equals 7 plus or minus the square root of 33. And that is my exact answer. Now, we also want to get the approximate values, because if I say something is 7 plus the square root of 33, that doesn't mean a whole lot. So if I take 7 plus the square root of 33 in my calculator, I'm going to get 12.74-ish. And then I'm going to take 7 minus the square root of 33. And that's going to give me 1.26-ish. Okay, so these are the values that like the book has in the back. But I also want you to give me the exact answer here. 7 plus or minus the square root of 33. Okay, and then again, to find those two answers, I just took 7 plus the square root of 33, and I took 7 minus the square root of 33. Same idea here, guys. Feel free to pause and give this a try if you'd like. Again, we've done where we took the square root of both sides, but here we don't have a perfect square on each side yet. We've also solved by factoring when nothing multiplies to 15 and adds to 9. So we're going to complete the square. And in order to do that, I just want my x squared and my bx term on one side, because I have to figure out what value I could add for my c value to make this a perfect square. Because once I have a perfect square trinomial, I can write it as something squared, and we can solve it the same way that we have been. So I take my b value, and I half it, and I square it. And I'm going to strongly encourage you guys here to keep these as fractions. So 9 squared is 81, and 2 squared is 4. And I add that value to both sides. Okay, I've completed the square. Okay, x squared plus 9x plus 81 over 4 has completed the square. Now, to write this as a binomial squared, because that's the purpose of completing that square and adding that 81 over 4, I take in my parentheses that I already have over here, and I put x, and since this is a positive 9 over 2, I'm going to do plus. So my factors are x plus 9 halves squared. And if I were to FOIL that back out, I'd get to x squared plus 9x plus 81 over 4. On the right side here, okay, these are fractions. We're going to combine them as such. Common denominator is 4. So if I multiply the bottom, I have to multiply the top. I get negative 60 over 4 plus 81 over 4. Guys, we're just adding fractions here. You can also do it on your calculator if you don't feel real comfortable, but I would do it as fractions. This is going to give me 21 over 4. And again, that's because I got my common denominator. I write 15 over 1 to make it a fraction. Common denominator is a 4. So to multiply from 1 to 4, I have to do the same to the top, which gives me a 60. So negative 60. Now that I have a common denominator, I keep my denominator, add across the top, and I get 21 over 4. Now, to get rid of my square, okay, again, once we get to this point, it's not new. We're solving it the same way that we have been. So to get rid of a square, I take the square root of both sides. And when I do that, I take plus or minus the square root. And 21 isn't a perfect square, so I leave that inside my square root, but 4 is. The square root of 4 is 2, so I took that out of my root there. Now to get x by itself, I subtract 9 halves. Okay, and that's because the square root of 21 is just the square root of 21. 21 is not a perfect square. But when I take the square root of 4, guys, I get 2. So I take that 2, it's no longer inside my radical, and it goes in my denominator there. Now, I'm going to write this a little bit differently. I'm going to put my number part first. So negative 9 over 2 plus or minus the square root of 21 over 2. And again, since our denominators are the same, if we really wanted to, we could write negative 9 plus or minus the square root of 21 over 2. And that's going to be my exact answers. Now, to find my approximate values, I'm going to take -9 plus the square root of 21. Either press enter there, guys, and then divide by 2, or you have to put your numerator in parentheses. Here, I should get approximately -2.21. And then I'm going to take -9 minus the square root of 21. And again, either press enter there and then divide by 2, or put it in parentheses. And -6.79 are my approximate values. So we want the exact answer, -9 plus or minus the square root of 21 over 2. And then we also want our approximate values. Now, we've talked about quadratic equations in standard form, but another form is vertex form. Y equals, in parentheses, x minus h squared plus k. And this is going to be a parabola with our vertex being at hk. So remember that middle point, that maximum or minimum, is our vertex. We can use the method of completing the square to find the vertex of quadratic functions of the form x squared plus bx plus c. And vertex form makes it a little bit easier to graph. So here, first thing we're going to do is I'm going to plug a 0 in for y for now. Now, our first step for completing the square here is going to be the same. I want to move the 8 to the other side. Okay, I want just the terms that I'm working with, my ax squared and bx, to be on the same side. Now, I take my b value, here, 6, half it, and square it. And I got that 6 from here. Gives me 3 squared, which is 9. I add 9 to both sides. I'm going to simplify here. 1 equals, and I'm going to write this in factor form. And since I had a positive 3, it's just x plus 3 squared. That's the binomial that I could square to get back to x squared plus 6x plus 9. Now, instead of solving here, guys, I want it to just be in vertex form. So I'm going to move my 1 back to the other side. And then I'm going to put my y back. And guys, we don't have to take our y out to start with if you don't want to, but sometimes it's a little bit easier to think about it that way than if we have that y there. Sometimes people are like, okay, I have a y, what do I do with this 9? I don't know. They panic. Don't panic. Okay, just take the y out, put a 0 in for now, and then just make sure you put the y back. So this right here is our vertex form, and this was our standard form. And from here, we can pull our vertex. One thing to remember though, guys, is that it's x minus h. So here when we have x plus 3, we actually have x minus, and our value that was plugged in was a -3. Okay, 2 negatives is how we get to that positive. So my vertex is -3, -1, h, k. It's like x minus -3, and that's how I get to minus a negative gives me the plus. Okay, so it's the opposite of what's in our parentheses, and then the same as what's after. So -3, -1. And we could have found the same thing, guys, by doing -b over 2a and plugging that back in, but this way works just a little bit easier than doing our table of values. Okay, so our vertex is at -3, -1. Big thing to remember here, guys, is it's y equals x minus h squared plus k. So we keep the sign in front of our k value, but we change the sign. That minus there means the opposite of h. So we take the opposite of what's in our parentheses. Instead of x plus 3, we take a -3 out. And I will continue on in another video.